Let's figure out which of these possibilities works. I've got my synthetic division all set up right here under example 2. I'm going to look at my list and just pick one. Let's just start in order. Let's just start with positive 1 and make that our box number. And we're going to do our synthetic division here and see if we have a remainder of 0. If we have a remainder of 0, that means this is a 0. This is a factor. That box number works. If not, we check it out and we try a new one until we find one that works. So, synthetic division. Bring my 2 down. 2 times 1 is 2. Add negative 3 plus 2 is negative 1. Negative 1 times positive 1 is negative 1. Negative 8 minus 1 is negative 9. Negative 9 times 1 is negative 9. And negative 3 minus 9 is negative 12. That is definitely not a remainder of 0. So I can come back up here. Positive 1 did not work. So let's try negative 1. So bring my 2 down. 2 times negative 1 is negative 2. Minus negative 3 minus 2 is negative 5. Negative 5 times negative 1 is a positive 5. Negative 8 plus 5 is negative 3. Negative 3 times negative 1 is a positive 3. And negative 3 plus 3, there we go. We finally got a remainder of 0. That means x equals negative 1 is one of the zeros for this problem. We'll notice that it is a degree 3, so we should end up with 3 zeros. Negative 1 is one of them. Now, once you find a 0 that works, write out your multiplication statement, just like we did in 2.3. So I have 2x cubed minus 3x squared minus 8x minus 3 equals... Now, if this is my 0 form, remember we have to do the working backwards step to get it into factor form. So I'm going to add 1 to both sides. My factor is x plus 1 equals 0. So x plus 1 is my factor. And let's see what I've got left. This is a remainder. No x's, x to the first, and x squared. So I've got 2x squared minus 5x minus 3 with no remainder. So you'll see right here we are getting closer and closer to factored form. And if you remember from 2.3, the key is we have to do synthetic division until we get down to a quadratic. Once we get down to a quadratic, that means we can try factoring it, or if factoring doesn't work, we can do our backup plan of quadratic formula. So I actually don't need to do synthetic division here anymore. I have a quadratic, so that means I'm going to go right ahead and see if I can factor this. So 2 times negative 3 is negative 6. I need to multiply to negative 5 and add to negative 6. That's like negative 6 and positive 1. So I'm going to exchange my negative 5 for a negative 6x and a positive 1x. Same thing, just exchanged it out. Now I'm going to look at the first two. It looks like they have a 2x in common. Look at the second two. They have a 1 in common. So to factor this all the way, I have a 2x plus 1 and an x minus 3. So this factored all the way. This is now my factored form. So if the problem asks you for your factored form, you can stop here. You're done. This form is fully factored. This is this equation, but all factored out. Now, notice this problem doesn't ask for our factored form. It asks for the zeros. So to find the zeros, we take each of our factors, set them equal to 0, and solve. So I get x equals negative 1, x equals negative 1/2, and x equals 3. And we said at the beginning that this is a degree 3, So I should have 3 zeros, and I do. So far, so good. So these would be my x-intercepts. Notice they all happen once. They all have an exponent of 1 on their factor, so they'd all have a multiplicity of 1. Meaning that when I graphed this, they would be my x-intercepts at -1, -1/2, and +3. And because they have an odd multiplicity, they would all cross through. A graph would look something like that. So that's the whole point of factoring. Get it into factored form. We can find our x-intercepts and their multiplicity, and then it's way easy to graph it. Now, one last thing before we move on from this. I hope you noticed all 3 of these answers, they're on our list of possibilities that we started with. There's -1, there's -1/2, there's +3. So that's one way that we can know, we had mentioned from the beginning, that our list of possibilities, those are all of our possible rational zeros. That's what this list does. This list says from all the numbers in the whole world that you could try out here and see if they work, our numbers are going to come specifically from this list. So we narrowed it down from an infinite number of numbers to try to just 8. That is the power of the rational zeros theorem. Now, one other thing I'd like you to notice before we end this video is in the problem, you knew that all these zeros were going to be rational because this problem said find all the rational zeros of f of x. That was a little hint to you in the instructions that all of these zeros were going to be rational numbers, numbers that can be written as fractions. If you see a problem that says find all the real zeros of f of x, well, real is a combination of rational and irrational. So that would be a hint to you in the instructions of the problem that your answers are going to have rational and irrational numbers. A little hint for the irrational means that this part, once you get down to your quadratic, it's probably not going to factor because irrational numbers are roots. So you're probably going to have to end up using the quadratic formula. So that is example number 2. In the next video, we're going to try example 3, where we try 1 to the 4th power, degree 4.